The Tsitsikamma Living Lab is the opportunity where we bring the theory and the practice together. The students in class learn about theoretical aspects related to marine ecology and specifically their intertidal ecology. We take a look at all these different aspects from different perspectives. So we have a look at it from a very narrow underwater perspective to a broader landscape perspective. Learning by doing is probably one of the most effective ways of teaching course content to students.
This Living Lab experience forms part of the Northwest University Honours course in estuarine and nearshore marine ecology. It fits into our program of aquatic ecosystem health as well as biodiversity and conservation. We're here at Tsitsikamma National Park at the south coast of South Africa. It's a biodiversity hotspot area, so it's a perfect place for a living laboratory looking at intertidal zone animals. If you want to do ecology, you really need to know what is the organisms that you work with. The first day is actually for them to have this opportunity to explore the intertidal life that we find here in Tsitsikamma. They have an opportunity for about 4 hours to explore the intertidal region between the high tide mark and the low tide mark and collect photographs of all the different animals that you find there.
Activity today is biodiversity, so we were just collecting samples of different species that appear in this specific area.
Each country has its own species, but here it's like species tenfold.
It's been really interesting finding things that I've never seen before, most of the things I've never seen before.
It was very surprising to see how diverse the area was, just from walking maybe a few meters.
Diving into the water and swimming next to the fishes and the different kind of species that are surrounding us. It's pretty cool, yeah.
Well, I'm hoping to learn more of the things when we go back.
It was really fun. I didn't think it was going to be this much fun.
It was a lot of fun. It was hard work for sure, but it was amazing. I mean, it's something that I'll never forget for sure.
We want from them a little booklet on the intertidal life that we find here in Tsitsikamma. There we would like to see some creativity. What do they do for a front page, a little bit of introduction and then discussing the animals, but also getting it scientifically correct.
Yesterday the students looked at the biodiversity, and building on that we're now looking at why the organisms are positioned where they should be positioned or where they are positioned. We are going to be looking at vertical distribution patterns of the organisms on the rocky shore. They're going to be setting up a transect and then looking at what organisms are found at every 50 centimeter vertical interval on their transect that they've done. Later on they'll be doing some calculations to work out abundance and percentage cover of the organisms at each vertical interval, and then they will also be drawing a profile to show their specific transect as to what organisms are found where within their zone.
I really think an activity like this is important to us because when you're busy checking these organisms, you need to see the movement, the way they live, where are they adapting, their adaptations.
In different level of the shore, they will have different kind of species.
And what we found out is that the majority of the species, they concentrate on the middle shore.
There's a lot of barnacles because there's a lot of wave actions.
Maybe because of the geological structures or because of the physical environment.
So you need to come to see them in their living environment.
We will then take that information, collate it and put all 4 groups worth of information together and show them that in more exposed areas on the coastal zone you'll find a higher abundance of organisms with a much greater percentage cover, and in the least exposed areas that the organisms will be fewer and will be different to those found in the exposed zones on the coast.
Just this whole experience is absolutely gorgeous. I've never been to an ecosystem like that, so I'm just falling in love. This is helping me a lot to be able to go out and do these certain activities on my own.
Providing me with some insight on what should I do and what should be my mindset when I study science in my further career.
During this activity, we're hoping that the students will get to understand the influence of tides on where an organism is situated on the coastline and how the abundance and size and shape of the organisms will affect where they are within the vertical distribution.
So far we've been looking at the species diversity, we've been looking at where they're distributed.
Day 3 is all about looking at what they do. So we're trying to find out the interactions between species. The students are going to design their own experiments. They learn about experimental design. And then they'll put that into action by looking at how predators and prey interact. We've given the students 4 examples of interactions that we've seen between predators and prey. Each one has a slightly different focus. So we're looking, for example, at some limpets which maintain their gardens. That's a resource they want to protect. One is the response of a group of evolutionarily related snails called the oxystele snails. Another one is looking at how the response changes with age in a limpet species, from the small limpets, which perhaps are not going to face up to a predator, to the large ones which perhaps are big enough to do. And then the last one is combining, I guess, 2 different behavioral responses. One is there's a little limpet called Halcyon, which actually likes to live underneath rocks. It doesn't like being in sunlight. But also, of course, it's not going to like predators. So we're going to see which is the strongest behavioral response, to escape from the sun or to actually escape from the predators. They've had some time in the evenings to plan their experiments, so they've thought about how they're going to do it, what equipment they need, and now they're going to go out and do it. And I think they're going to find that actually it sounds great when you plan it in the lab, but actually going out and doing it is actually slightly different.
This really excited me. Like every morning when I get up, I'll say, oh, it's time for us to go to the shore. It's time to discover what's new.
Today we are looking at predator-prey interactions with limpets and sea stars.
We are doing an experiment on the prey and predator interactions on a rocky shore.
Usually what we see on the shores, they're like not moving, not doing much, but in the real life, they're doing a lot of interactions.
One of the experiments that our group has designed, and that would be a predator-prey relationship between some of the top shells and also one of the dog wells. We'll have a stopwatch, so after 30 seconds we will measure. One is the specific distance, how the prey species would travel, and one is the direct distance between the predator and the prey. So we can see, what direction is really moving or is like going around in a circle.
We are taking the sea star, leaving the limpets in their natural environment and exposing them to the predator, which is the sea star. Our hypothesis is the bigger the limpet, the less reaction it will show towards the sea star, and hopefully it fights back.
So we believed that they would react certain ways, and clearly the experiment showed that they don't. They react completely different from what we thought would happen. So it gives you a lot of practical experience. It gives you a lot of insight to what would actually be expected of you if you were to go into this direction, and what is needed for people that's going to do, the practical work and the field work.
Day 4, of course, builds on day 3 and day 2 and day 1. My module blows all that up, looks at all that diversity, where it is, and then how all of it's interacting with one another through trophic connections or connectivity. The students today will learn about consumptive pathways. So there's transfer of energy between the land and the intertidal, the open ocean and the intertidal, so it's connected. We have 4 teams, and each team is going to take on one part of that bigger puzzle. The way I like to run this is that each team does not know what the other team is doing, so that in the end, the whole picture will be revealed, but each group will not be influenced by what the other group is doing. So the first group is looking at primary productivity. The second group is looking at fishes. So fishes are much more mobile. The third group is working on what we call allochthonous input, that is input from the outside. The fourth one, which I call like the secret weapon, are the parasites. And in fact, the parasites often influence the likelihood that something else is going to be eaten.
Our group specifically work on the external effects on the nearshore marine environment. If you look at the terrestrial inputs, which can affect the river, which eventually affects the nutrients flowing into the nearshore marine, that feeds the algae and in turn feeds the rest of the food web.
In the morning, we go into the lab in tents and see those microscopes. Yeah, we can see some tiny fat worms and those parasites, and they also do the digestion of the fishes.
It was interesting to see it basically come to life, because we always just learn of it on a piece of paper 2D, Instead of being stuck in an actual lab, you get to experience the whole setting, the whole area in which it actually happens.
It's more than just that little lab that we see. It's just nice to see the bigger scales as well.
Being exposed to different kind of ecosystems will help me to get a more comprehensive idea of what is the ecosystem going on. I think it would be great to have such kind of platform provided that we can exchange our knowledge, information, and just cultivate new ideas.
One thing that's unique about this module is that we have them act out their component, their part of the food web. It's a lot of fun, actually.
Highlight should be the drama, you know. After we know more about the parasite, we'll have the drama to present the importance and the status of parasite in the trophic level. It's very creative.
You can live straight in its eye. So just whatever y'all want to choose.
Left, right, left. Blacktails. Dead octopus.
Dolphin.
This is day 5 and we're doing estuarine ecology. Before the start of today, the students were briefed about all the various activities and techniques that they will be experiencing during the day. We highlighted the different types of estuaries that we find in South Africa, and the Groot River estuary being a temporary open-closed estuary. We're hoping to see how the habitat characteristics have changed from the headwaters of an estuary that is influenced more from the freshwater inflow from the river, and we'll also do some electroshocking for fish that is found at the headwaters of the estuary.
We went to Nature's Valley Bridge where the freshwater meets the seawater.
We were there to determine the species diversity.
Upstream, we did macroinvertebrates, so we would disturb their habitat, count again and identify which species was present. We also did electrofish shocking, again to see which species made it up so far in the stream.
As you move lower down into the estuary, the marine influences become stronger, and that will then change the communities and the different invertebrates and fish that you find there because of the higher tolerance to seawater and salinity that we expect to increase in the mouth of the estuary. Here we will use benthic grabs to look at invertebrates, and then we'll also look at using seine nets, various small ones and larger seine nets, to sample fish from the estuary mouth and the estuary lower reaches.
I have the fish in my hand and also have the guide, and I clip the book to find out the identity of the fish.
We have noticed that upstream there is a lot more species diversity compared to the downstream where the river actually opens up to the mouth.
The students need to experience the different habitat types and how it changes from the headwaters to the mouth of the estuary.
Today we find the same species fish that we find in Hong Kong. It's called wu tao in Hong Kong. It is also the fish species that we will eat and sold in the market.
We come from Poch and seeing the sea and also where the river meets the sea. It's going to give us so much more knowledge in terms of practical use.
It's very interesting and very unique experience to me.
So historically, the park was established in 1964, 57 kilometers. Tsitsikamma is the oldest marine protected area in South Africa, so it makes it worth studying from an environmental management perspective. And so what we try to do with the students is introduce 3 different environmental management approaches. We expected them to apply these approaches to specific challenges. The specific challenge we looked at was the recent allocation of fishing licenses for recreational fishing within the park. We covered 3 different approaches, so we looked at what should typically be in regulations. We also looked at some of the fiscal measures, and then we also looked at civil-based instruments. So the idea was that the students should apply their minds and think about ways of how can we manage potential impacts related to recreational fishing in the park.
One of the reasons why we're so successful being able to present this living lab is because of the support from sandparks. They've always been supportive from the start of getting permits and even getting the campsite sorted out. We also use this opportunity to collect data that then can filter back into the databases of sandparks. It's not just about training students, but also provide them with relevant data that they can use in managing of the park.
It's always nice to have visiting researchers use the park because we try and promote our parks as natural laboratories. There's a potential for us to collaborate on the work we do as park management with researchers so that we can utilize our resources better. To see it used to teach students is quite exciting.
When you get into it, it's really fun because the students.
When they do the living labs, not just our Northwest University students, this is an international living lab, and it consists out of students from Northwest University, students from University of Johannesburg, and then we've got our colleagues from Hong Kong University that bring a group of students, and also from America, Arkansas State University. It's a multicultural experience for the students, and the theme that binds them together is this amazing ecosystem that we find here at Tsitsikamma.
One of the most important things about science is diversity. An international experience like this, it brings people together from not only different institutions or countries, but also different backgrounds. So these people have different ways of looking at the world and also different ways of interpreting it. And by doing that, you can combine your knowledge and then produce a better understanding of how the world works.
The mix of cultures was the most impressive thing about this Living Lab experience, because it's from 3 to 4 different cultures coming together and just seeing how other people's perspective on life is and how they see this type of biodiversity is just amazing.
A bunch of colleagues that are coming from everywhere. I love this culture exchange and also doing work together. It feels so good.
They're learning their own strengths and then how to apply those with people from different backgrounds and how to work together.
Even though we are doing science, we are not just working alone, we work together.
So it's cool that we can all relate with the knowledge we bring from our background and our home ecosystems and merge them together here.
Being exposed to cultures widens your view of the world, your appreciation of other cultures. So I think there's only advantages to different cultures mixing.
Atmosphere is excellent. Yeah, that's the only word I can give because I have never met so many black people and I have never worked with white people so closely. So it's really happy that I can meet a lot of new friends, but I think it's good for you to have a chance to try something new and something unfamiliar.
It's extremely important for these students to be exposed to different viewpoints, to different cultures, as well as being able to interact with the people from different cultures. And in that manner, it makes them citizens of the universe and citizens of the world.
Practicals like this are important as the students out in nature, they're doing a hands-on approach. It is possible to do it a lot easier with a lot more technology, but a hands-on experience gives the students a greater experience in what they're learning.
There's no better way of learning about ecology. You have to go out and actually experience it. And there's no other way of doing that than a living lab. The best thing about it is that you actually get students living together, working together and sharing their ideas together. And it's an incredible both scientific and educational experience. I don't think you can put money on it.
This is a brand new experience even to me. I come from Hong Kong where we are filled with technology and we study ecology. But the essence of doing ecology is back to the basic, like how do you get connected to the nature? And this course is like a condensed science journey.
It just shows you, what you miss if you just go through the books. You need to have this practical side, this fieldwork side in order to understand what really happens.
We just go to the field, we don't check on phone and go to literature, we just be there and observe. And we come back, we just look to the book and just explain what we see.
So for me, I would say living lab is definitely more important than lectures inside a lecture hall.
When I came here, there was not much that I knew about marine ecosystems, but I actually learned a lot. Everything was just new for me, and I actually snorkeled for the first time.
If you're going to be part of anyone that's doing environmental science or ecology, the living lab experience is what makes those courses for the students. And it's what they remember most of all after their time and what they appreciate most of all as well.
We're currently in the 5th year of the Living Lab And we almost had 200 students that has gone through this whole Living Lab experience. It's our hope that this Living Lab will continue for many years with the support from all 4 universities, and also that we can extend it so we can achieve more from collaborating with people from all over the world.
The experience that we as lecturers have had in terms of the students experiencing the Living Lab has been phenomenal, and it's our dream that we are able to provide this opportunity for more students in future, that we can really create a passion among our students for the marine environment.